Hey Dragons, today's lesson is over graphic domain and range. So by the end of this lesson we should be able to find the domain and range for something that looks like this. But before we do that, we'd like to break this down into its smaller parts. The graphing grid is made up of an x-axis that goes horizontally and a y-axis that goes vertically. So I want to go back a couple of years to when our life was a little easier, when we just had an x-axis. Okay? And as we go through this lesson, we need to make sure that we remember our synonyms for domain. That would be input, the x variable, which is the independent variable, and that is the cause, and the same thing for the range. We need to know that's the output, the y variable, the dependent variable, and the effect. So, as we take a look at this, some of the things that we need to know before we begin this is we need to remember some symbols from middle school and elementary school. We need to remember greater than, we need to remember less than, we need to remember greater than or equal to, and you guessed it, we need to remember less than or equal to. Now, there are some mathematical symbols that go with that. Greater than looks like this. Less than points to the left. Greater than or equal to means that we have a partial equal sign under the greater than sign, and the same thing with less than. Less than or equal to has a partial equal sign underneath that. So those are some that we need to remember. Now as we take a look at this graph on the x-axis, remember the x-axis is the domain, so on this particular problem we're looking for the domain because there's a whole bunch of numbers that are shaded right here. The shaded part is our solution. All right, and if you notice, we have an upper and lower boundary. Okay, these are closed dots. Some people would say they're solid, however you prefer it. Well, what does that mean? Closed and solid dots, it means that the number, in this case it's 2 and 5 that have the solid dot. It means that that number or numbers is part of the solution. Okay. Now, how do we go about representing all these numbers in between 2 and 5? Well, what we're going to do is we're going to say, all right, since these are numbers on the x-axis, we're going to say that the variable x represents all of the other numbers that are in between. Okay? So, as we go about looking for our domain, remember it's on the x-axis, so we're looking for the domain, the set of all of the numbers that are visually represented here. What we're going to do is we are going to say that our solution is going to be all numbers between 2 and 5 inclusive. Use that word inclusive because of the solid dots. Solid dots means that we're going to be using those numbers as points. So what we're going to do is on all of these problems we're going to do a setup that looks something like this. What we're going to do is we're going to say over here on our part down here, we're going to say that we're going to have a low number on the left. A low number is always on the left. We're going to have a high number over here. Okay? And then what we're going to do is we're going to have all the numbers actually go between the low and high number. Now if we take a look at these symbols, greater than, less than, greater than or equal to, less than or equal to. If we're going to start with low and then go to high, we're going to use either less than or less than or equal to. Okay? So we're going to have either less than symbols or a combination of less than or equal to. One or the other. So every single problem that we're going to look at is going to be of this format. We're going to have a low number on the left. We're going to have the high boundary on the right. Everything that's in between is going to go in the middle, and we're going to use less than symbols. Less than symbols. It doesn't make any sense to do greater than symbols right here, because then I would be saying that the low number is greater than the high number. Use less than symbols. Let's come over here and reiterate, say one more time, what kind of dots goes with these symbols. Okay, so greater than is going to be an open dot. So I'm going to just put an open dot here to remind us that greater than is open dot. If I'm greater than 5, I'm not equal to it, so I'm not going to fill it in. Same thing with less than. Those are going to be open dot here. Anything that is equal to, like I have up here, is going to be a solid dot. Same thing with less than or equal to. All right. So if I come over here, I use the word inclusive. So if I come over here, I can say, okay, greater than or equal to looks like this symbol. It has a closed dot, and I'm going to see the word inclusive. Same thing for this. Here's the less than or equal to symbol. It's going to use a solid dot because it's equal to, and that means that I'm going to include that point. So what word do you think would go with these symbols that have an open dot that do not include it? Well, the opposite of inclusive is exclusive. So we're going to use that word later on when we see open dots. All right. So what we're going to do now is we're going to take this information right here and we're going to write what is known as an inequality statement. An inequality. And the inequality statement is based on this right here. Okay? So let's look at our picture. What's the low number? The low number is 2. Put it on the far left. What's the high number? The high number is 5. Put it on the far right. How many numbers do we have between them? We have a whole bunch. We're not going to try to list them. We're going to let the variable x represent all of the numbers. So we're going to put that in between. Okay? And we know that low is always less than high, so we're going to use less than symbols. So we're going to throw less than symbols here. But we need to check our dots now. Are they solid or are they open? Well, they're solid. So I need to do less than or equal to. So I'm going to come in right here, and that is going to be my answer. This is my inequality statement that represents this picture. All numbers between 2 inclusive and 5 inclusive. So right now, if you would please, go to your handout and try example 1 and select your answer on that puzzle. All right. Here's our next example. These are going to go a little faster as we continue to go along here. All right, so what we notice here that we didn't have in the previous one is we have this big arrowhead. What does that mean? Okay, that means that we are going to go on forever. This goes forever to the right. So we need to introduce the concept of infinity. Okay, so our infinity, we might want to put it down here. Infinity symbols. We have 2 of them. If we are going to the right, we're going to positive infinity. It's kind of like a sideways 8 that's been stretched out. If we go to the left, we have negative infinity. Okay, so on this number line, which again is going horizontally, so this is a x-axis, right? So we're talking about the domain. So my domain, we want to find the domain of this thing. Okay. We're going to have positive infinity going over here to the right. All right. So what's my low number in this problem? My low number in this problem is right here. It's a 7. Okay. So following this pattern right here, my low number is going to be a 7, so I'm going to write that first. Now what's my high number? Well, if it goes on forever, we don't have a high number, we have a high idea. Infinity is a concept. So you can never tell me what the highest number in infinity is. So the way we're going to get around that is we're going to pull this little guy right here, and we're going to say you're going to represent the high numbers. Okay? So my low number over here, my low number is a 7. My, quote, high number is a positive infinity because it's going to the right. Now, what about all this stuff right here? What about all this shading right here? Well, we're going to let the variable x represent all of the numbers that are higher than 7 and go on for infinity. Okay? So again, let's talk about our dots here. We got an open dot. An open dot, if we look up here, means that we don't include 7, but 7 kind of acts as a lower boundary. Okay? So an open dot means that the number is not included in our solution set. It acts as a boundary. Okay? So all my numbers, we're going to let x be in the middle. What symbol do we always use if we go low to the left and high to the right? We use less than symbols. And put it right here. All right. And we got to figure out, all right, we know that this open dot right here is not going to be an equal to sign. Okay, so we're not going to use equal to, we're going to use just the less than symbol. But what about infinity? Can we touch infinity? No. Okay, so we're going to make a statement down here with infinity. We can't touch infinity. It's a concept. So what does that mean? We're going to use simply the less than symbol with infinity. Okay? So think of infinity as having an open dot over there. And so, ladies and gentlemen, we have just found our domain. All right? We have all numbers between 7. I'm going to write this down. I'll say all numbers between 7 and positive infinity, and since we have open dots and we can't touch infinity, we're going to use the word exclusive. Okay. And so that is our verbal statement. This is called our inequality statement, and because it is on the x-axis, it is the domain. All right, try the next one on Edpuzzle and see how you're doing. All right, we've got another example right here. And let's see how fast we can go through this using what we've learned so far. We've got a low number of -4. We've got a high number of -1. And all of our other solutions are between that. They're in between that. So we're going to let x represent that because it's the horizontal axis. Because it's the x, we're finding the domain. And right here with the -4, we have an open dot. Open dot is exclusive, so we're just going to use less than. And we always use less than with the low and high setup. But over here, we're looking at the -1. It is closed, so we're going to include that point, and the way that we show that is by making that less than or equal to. So this is all numbers between oops, one too many E's, between negative 4, and that has an open dot, so we're going to say exclusive for negative 4, and we're going to go to a high of all numbers between negative 4 exclusive and negative 1, and that's closed. We're going to say inclusive. All right, try number 3 on your Edpuzzle handout. Alrighty, so again, we're just looking at some examples. I want to get as many as we can right here. We're looking at a domain problem because it's horizontal, so we want to find the domain. Alright, what do I notice? I got my low number heading this way forever, so that's negative infinity is my low number. My high number is 2, and all the other x's are in between. So low, negative infinity, high, 2, in between all the x's. We always use less than symbols. Can't touch infinity, so we'll leave that symbol alone. We'll look at 2, it is closed. And to show that we do include 2, we're going to put an equal to sign there, and that is your domain. All numbers between negative infinity exclusive and positive 2 inclusive. Alright, try number 4 and answer that on Edpuzzle. Alright, the other aspect to the graphing grid is this vertical axis, this y. And so what we're going to do is we're going to kind of play around with that as well. This time we're going to still use the same concept. All of the symbols, all of the low, high, etc., infinity, all of this stuff is still in play for all of these problems. But when we go vertical, we're going to have to say that this is my y-axis. All right, so the y-axis goes up and down, so we're going to be finding the range on this problem. And well, where's my low and high? My high is up, my low is down, and well, in between is well in between. Okay, so I'm still going to ask myself as I look along the y-axis, what's my low number? Well, my low number is negative 2. What's my high number? It's 1. What's in between? Well, on the y-axis, we're going to say all the y values are in between these two guys right here. So I'm going to put a y right there. And even though it's going up and down, we know that from left to right, over here, from low to high, we're going to use less than symbols. We always use less than symbols. Less than symbols are the easiest. Low, medium, high. Use less than symbols and everything's good. Okay? And we'll just check our dots. Open dot, leave it as less than. Closed dot, we need to include 1, so we'll do that by saying this. And ladies and gentlemen, this is your range. All numbers between negative 2 exclusive and positive 1 inclusive. All right, give one a try. Number 5 on your Edpuzzle. All right, here's another one. Real fast. I want to make sure that we have the idea that yes, we can have infinity on the y-axis. We got that big arrowhead, and we're going up. Remember, this is high on the y-axis, and this is low on the y-axis. So positive infinity would go up, and negative infinity would go down on the y-axis. But in this case, I do have a low number. My low number is negative 2. My high number, I don't know what it is, but we'll just let positive infinity be the high number. And then all the other y's are in between. We always use less than symbols. And we ask ourselves, do I have open or closed dots at numbers? In this case, it's closed. So here we go. So my range in this problem is all numbers between negative 2 inclusive, closed dot, less than or equal to, negative 2 inclusive, and positive infinity exclusive, because we never touch infinity. All right, try the last one on for just the y-axis. 6 on your hand nut. Try that, see how you're doing. And now we'll get to the nitty-gritty. All right. So now we're going to combine everything. Now if you notice in this particular problem, I'm going to try to make it a little bigger. All right. We have two things going on here. Okay. We have to find my domain, so we need to do a low, between, high for the x-axis. And we need to do the same thing for my y-axis, or my range. Alright, so when we have a problem like this, the first thing you're going to try to do is you're going to try to frame this bad boy. Well, what do I mean by framing the picture? Well, we're going to try to put this in a rectangular frame so that each side of the frame is touching the graph. Now I want you to notice what I just did right here. This is the smallest frame, rectangle. I've got to have right angles. This is the smallest frame that actually encloses all of this picture. I didn't want to do something out here because I wouldn't have it touching. I want to squeeze this thing in as far as I can, both left and right, and I want to squeeze this thing going up and down. All right? So, as we do this particular problem, what I want to do is I want you to look. I want you to look over here. Look at the values that touch this quote frame, and that's going to give you your high-low or low-high points. Okay? So, as we take a look at the domain, we have to remember that we're on the x-axis. So when I'm looking for my high-low, I'm not going to be looking at the graph. I'm looking at the frame. Okay? We're looking at the frame to get your high-low. Okay, so on the x-axis, if you notice, I touch right here. Well, what's that value? Well, that value is from the origin -1, -2, -3, -4, -5, -6, -7. My low value is, on the x-axis, is going to be a -7. Well, what's going to be my high value? So I'm going to stay on the x-axis and I'm going to go to the frame. 1, 2, 3, 4, 5, 6. My high value is going to be a 6. Alright? And so everything else is in between, just like our previous practice problems. We've got a low, we've got a high, and all the rest of these points constitute the x values that are in between. So x goes in between. What inequality symbols do we always use? We always use less than. Low is always less than high. Alright? Now, we'll do the same thing, or excuse me, before we go on to the range, let's take a look. Now to determine if this stays less than or goes to less than or equal to, we're going to look at the dot. Okay, so now over here, let's go to the graph. At -7, the graph has an open dot. So that is exclusive. That is less than. This guy's going to stay by itself. But let's go on the high end. On the high end on the graph right here, I don't see an open dot. I see a point right here. I'm actually touching this right-hand side. So in order to include this point right here, I need to make this a less than or equal to. All right? So what did we do for the symbols? We're going to look at how the graph touches the frame to determine whether we're going to use an open dot or a less than symbol, or whether we're going to use a less than or equal to symbol. So over here, the graph was open, so I used the less than symbol. But over here, on the high side of the x values, it wasn't an open circle, it was an actual dot. It wasn't a big one, but it's still closed. So we use less than or equal to. So now we're going to do the same thing for my range. Okay? I'm looking at the values for my high-low. I'm looking at the frame that's touching this. So my frame right here on the y-axis, my low frame goes down -1, -2, -3, -4. And my high values on my frame goes up to 1, 2, 3, 4, 5, 6. Alright, so look at the frame for your high-low. Now, to determine if it's going to be less than or equal to, look at your dots. So up here at my high point, look at the graph, that's an open dot. So I need to leave my high point with less than. But now let's come down here to the low. Down here at the low point, if I look at the graph has a closed dot down here. So in order to show that I'm going to include my low range value, I'm going to put an equal to sign right there. And this is the domain and range for this function. Alright, go ahead and try example 7 on your Edpuzzle, see how you do. Alright, and we'll do one more right here. Alright, and we're going to do it the same way. We're going to try to put a frame on this bad boy, but the only problem that I see is this right here. What do I see? What do I see right here? I see to infinity and beyond. Alright, so Buzz is saying right here, we got infinity going down this way. How can I make a picture frame on something that goes on forever? To infinity and beyond. Okay, so we can't do a frame down here. If it keeps going, I can't frame which way can I frame? I can't frame left because it's going left. And I can't frame down because this graph is going down and left. Okay, so I need to bring in infinity going to the left, so I need to bring in negative infinity, and I need to bring in negative infinity going down. However, I can put a top frame over here like this. I can frame the top and I can frame the right. So here we go. Let's find our highs and lows. Okay? On the x-axis, my low is going, I can't find the low because it's going forever. So my low is going to be negative infinity. But what about my high? Well, let's come over to here, and right here, I touch the frame. So that's my high. My high is going to be a 10. Okay? What symbol always goes with infinity? That's right, less than. We can never use less than or equal to. We can't touch infinity, even negative infinity. But over here, I'm going to look over here at my picture. I got 10 from the frame, but now I look at the graph, there's an open dot at 10, so I'm just going to leave it like that. So, is this my domain or my range? My x values, this is my domain. So now let's find the range. What's the high value of my y-axis? I can frame that, I frame that, and it goes up to what? The high value is going to be a 7. What about my low value? Alright, he's going down to infinity and beyond. Had to say that. Okay? Alright, we have a less than symbol, but now let's go check up here. Let's go check the graph at the top frame, at the graph. Ooh, look right here. Look right here. These points right here. Do I actually touch a 7 at these points right here? I do. Even though there's an open dot right there, I am touching it right here, and so I'm going to use a less than or equal to. Alright, try the last example. And remember, if you study, U2 can go to infinity. and beyond.